For today's lesson, we're going to learn how to convert fractions into decimals. And why do we need to know how to do this anyways? One of the reasons why is that when we're comparing fractions and decimals, sometimes it's harder for us to visually see the difference in the value. And so having them in the same form really helps us to clearly see which number is greater or less than the other one. So that's what we're going to be doing today. Let's get started. So if you've been following along in your workbook, we are in Chapter 4, Fractions Meet Decimals. If you'd like a copy of your own workbook, you can visit theblazehaven.com. So our focus for today is to convert fractions into decimals by using division and reasoning. And we do this so that then we can compare and order any type of rational number in a real-world context. So our question that we want to be answering is, how can we use what we know about division to help us to understand and explain the relationship between fractions and decimals? Before we jump into converting fractions into decimals, we're going to be doing a lot of dividing. So we want to remember some of our key vocabulary terms. First, the dividend is your numerator, or the number that goes on the inside of the division tent. Then your divisor is your denominator, or the number that goes on the outside of the tent. Okay, and your quotient is your answer. Quotient is the answer to any division problem. And then we want, as we're going to discover some patterns as we are dividing fractions and turning them into decimals, we're going to see that we have terminating decimals and repeating decimals. And a repeating decimal is where the number repeats over and over and over again. And an example of that would be 1/3. When we convert 1/3 into a decimal, it's 3/10 or 0.333333333333333. But we don't want to write a gazillion threes, so we just write 3 with a line over it, and that's 3/10 repeating. The next is a terminating decimal. To terminate, I think of the Terminator. To terminate means to stop, and so it's a decimal that stops. It doesn't go on and on forever. When you move into 8th grade, you'll learn about irrational numbers, and irrational numbers have that when they're written in decimal form, the decimals go on and on forever and they never terminate. They don't stop. But for this lesson, we're working with rational numbers, and rational numbers are our fractions and decimals. And we either have a repeating decimal or a decimal that stops, like 0.2, 2/10, it's done. 2 is my last number. It's terminated, so 2/10 is my decimal. So we're going to start with a fraction. We're going to use division, and then we'll end in decimal form. That's what is the progression as we move from fraction to decimal. So let's look at the example 2/5. Okay, 2 is our numerator, 5 is the denominator. 2/5, the way you say it is also how you're going to write it out when you're dividing. 2 divided by 5. And when we work that out, we know that 2/5 equals the decimal 4/10. Okay, so remember that the numerator is what's being divided. That's the dividend, the number on the top. And then the denominator is what you're dividing by, the divisor. And in division, order matters. If I had 2/5 and I do 5 divided by 2, I'm going to get a completely different answer than I would get with 2 divided by 5. So we want to remember that all fractions are division problems, and that's how we find our decimal form. Now we are going to be converting each mixed number into a decimal. And remember, if we rewrite it as an improper fraction, your answer is always going to be greater than 1, and we'll be rounding our answers to the nearest 100th place value. So there's our ones place value, tenths, hundredths, so 2 digits past the decimal to the right of the decimal. So let's start with 2.5. And the first way we can do this is to convert this mixed number back into an improper fraction. And we do this by using the around the world method. And if you would like a full lesson on how to do that, check out the link in the video description. So I'm going to start with the denominator. 2 times our whole number is 2 is 4 plus 1 would give me 5 halves, and then I can do the fraction 5 halves. So I'm actually going to erase that so I have more space and write it down here. 2.5 is the same as the improper fraction 5 halves. So 5 goes on the inside of the tent, the 2 goes on the outside. And I'm going to start with 2 goes into 5 2 times, because 2 times 2 is 4. 5 minus 4 is 1. I add my decimal and drop in my placeholder 0. 2 goes into 10. 5 times exactly. I have nothing else remaining, so my answer is 2 and 5/10. The other way you can do this is leave it as a mixed number, 2.5. I know that the first part of my answer is going to be 2 point something, so you can just do the 1/2 instead if you'd like. 1 divided by 2. 2 does not go into 1, so I'm going to add 0, my place value holder, and 2 goes into 10 5 times. 5 times 2 is 10. And so then I have 2 and 5/10. Same answer. Okay, 2 different ways that we're doing it. Go ahead and try number 2, 3 1/3. So you can convert it to an improper fraction first, or you can write your answer knowing that the first whole number is 3 and find the decimal value for 1/3. There are 2 different ways you could have solved this. First, you could have converted this mixed number 3 1/3 back to an improper fraction. I'm going to use around the world. 3 times 3 is 9, and then 9 plus 1 would give me 10/3. So 10/3 is an improper fraction, and it has the same value as 3 1/3. I would do 10 divided by 3. 3 goes into 10 3 times. 3 times 3 is 9, with 1 left over. I bring down my 0, and what do you know? 3 goes into 10. I'm going to have the same pattern here. 3 times 3 is 9, with 1 left over. I bring in the 0. So we call this a repeating decimal. I know that the 3 is going to continue to repeat. So my answer is 3 3/10 repeating. Okay, you could have also started off 3 1/2. You don't have to convert it to a mixed number. I know that 3 is going to be the first part of my answer, and I just need to divide, not a half, a third, 3 1/3. I'm going to divide 1 divided by 3. And I'll show you how we still get the same answer. 3 does not go into 1, but it goes into 10 3 times. 3 times 3 is 9, with 1 left over, and then I see I'm going to have the same pattern again. So I know that the fraction, a third, is the decimal 0.3 repeating. So I have the same answer, 3 3/10 repeating. Now we are going to be comparing fractions and decimals, and we're going to determine which value is greater than, less than, or equal to. Okay, and we're starting with number 1 here, 6/10 versus 3/5. So since we are practicing converting fractions back into decimals, that's what we're going to do for all of these problems. Since I'm comparing a decimal to a fraction, it's easier to either compare a fraction to a fraction or a decimal to a decimal. So we're going to convert 3/5 as a decimal. 3 divided by 5, 5 goes into 3 0 times. I add in my decimal point. 5 goes into 36 times. 6 times 5 is 30. It goes in evenly. So 3/5 is the same as the decimal 6/10, and so the values are equal to. Let's go ahead and have you try number 2. Go ahead and click the pause button, and we'll come back and go over the answer. So 5/8 versus 7/10. I'm going to convert 5/8 back as a decimal. So 8 goes into 5 0 times, but 8 goes into 50 6 times. 6 times 8 is 48. I'll have 2 left over. I should have made a little more space here. 8 goes into 2. I'm going to drop in. 8 goes into 20. Let's see, 2 times. 2 times 8 is 16. 4 left over. I drop in my next 0, and 8 goes into 45 times. So 5/8 is the same as the decimal 0.625, 625 thousandths compared to 7/10. Okay, so 7/10 is greater than 625 thousandths, so the 7/10 is greater. So when I write my inequality, it's going to be, we're going to say the whole number sentence here. 5/8 is less than 7/10. Let's check our answer here. Again, I'm going to convert this fraction into a decimal, and this problem's a little easier because I already have 5 5/10 and 5/10. in decimal form. So 1.5, I'm just going to convert a half to a decimal. 2 goes into 1 0 times, and it goes into 10 5 times easily. This is a half is one of our benchmark fractions, so you should soon start to memorize that 1/2 is always the decimal 5/10. And so here we see we have a repeat 5/10, 5/10, and then 5.5, or 5 5/10 would be the order. We can also write it with, oh, I forgot the 1. That's why it's the same thing. It would be 1 5/10, or 1.5. So when we put them in order from least to greatest, 5/10, 1.5, and then 5 5/10 would be my greatest value. So there's my answer. Today we learned how to convert fractions into decimals, and really what you should have seen is the reason why it works is because all fractions are division problems, where simply they're just written in different forms. So when we take a fraction and rewrite it as a decimal, the reason why we want to do this is that if I have lots of fractions and decimals mixed up with different values, it's harder to determine which one's my greater or smaller value. And so if we put them all in the same form, all as fractions or all as decimals, then we can simply see which one is the greatest value, which one has the least value.